So let's talk about the working principle of a generator. So we say working principle of a generator. Okay, now a while ago I drew for you, okay, first of all, the working principle of a generator can be described in phases. Yes, in phases, and I'll explain to you what a phase is. First of all, you know, we drew the shape of the basic part of a generator this way. We say it has a horseshoe magnet of different polarities. And of course, if this is north, here will be south. Of course, you have to shade it to know the difference. So here we call here, of course, you have the magnetic lines of force running from north to south. So here's the axis of symmetry. Let's call this a Q or PQ. PQ. And then here is an A, B, C, D. So at the start, before you start the generator, we have this armature in the magnetic field such that it is positioned at 90 degrees to the magnetic field. And so since the armature has not turned any degree, we say theta here, which is the phase angle. In this case, theta is what? 0 degrees, because it's not turned in any way. So by the time we begin to rotate this armature, let's say we're rotating it to the right, sorry, in clockwise direction, such that AB will be moving out of the book while CD will be moving into the book. You see, so at the point where the phase angle is 0 degrees, we meaning this armature has not turned any angle yet. At that point, observation shows that the induced EMF is equal to 0. The induced EMF is equal to 0 volts. You see. Now, okay, now as it begins to turn, let's say, okay, at this point, because sine, you know, induced EMF according to this equation, BVL sine theta. If theta is 0, that means the whole of this, the induced EMF will be 0, because sine 0 is equal to 0, and then it doesn't matter what the value of this is, the induced EMF is going to be 0. Now, let's consider a situation whereby the armature has turned 90 degrees. So here we have the north pole of the magnet. We also here we have the south pole of the magnet. So it has to come this way. And then we have the magnetic lines of force running from north to south this way. So when at 90 degrees, that's when this armature has turned 90 degrees, it means it is now parallel to the magnetic field. So we have this way. So here we have A, B, C, D. And then we have a line of symmetry this way. It is Q or PQ. So in this case, now here theta is equal to 90 degrees. It's turned right angles already. Now at this point, the sides AB and DC are parallel to the magnetic field. Now observation shows that at this point the induced EMF is equal to maximum, because if you apply this formula, sine theta, when theta is 90 degrees, it means the whole of this is maximum. So E is equal to BV, which is equal to E naught. You see? So as it turns around in this magnetic field, an EMF is induced in this coil, allowing current to flow within the coil. So when the loop turns yet another 90 degrees, when the loop turns yet another 90 degrees, that is 180 from the initial starting position, then we have, this is what we have. Again, now the side AB has risen out of the book, while side CD goes into the book. So now we have here at this point, okay, we still have a line of symmetry here, PQ. Here theta is equal to 180 degrees. Now observation shows that the induced EMF here is 0. And that makes a whole lot of sense, because when you put 180 degrees into this equation, it gives us 0. And that means the induced EMF is minimum at this point. So what happens when, okay, at phase angle, when the phase angle is 270, what happens? Let's see. And then here we have the South Pole. Of course, we have the lines of force moving this way. So now we have once again the coil is now is now parallel to the magnetic field. So we have a line of symmetry this way. Here theta is equal to 270. Now the coil is parallel to the magnetic field. Now at this point, here will be AB, while here will be here will be AB, while this is CD. So at this position, when the phase angle is equal to 270 degrees, observation shows that once again the EMF is maximum. EMF is equal to E naught, which is maximum. But there's a difference here. The direction of the current induced reverses. Why? As that can be seen from the fact that sine 270 gives us a negative -1. You see, the result we get here is the same thing as the result we got when the coil turned 90 degrees. It's maximum. It's just that contrary to what happens here the direction of current changes. It alternates. It goes back in opposite direction to the direction of current at this point. You see? So again, now that's what happens when the coil had turned 270 degrees. That is 3/3 of a cycle. Now what happens when the coil has turned one cycle, which is 360 degrees? Now this is what happens. Experiment shows, or observation shows, that once again of course we have the sun line of symmetry here, A, B, C, D. So when the phase angle theta is 360 degrees, what happens? Observation shows that no EMF is induced. EMF is equal to 0 volts. And that makes a whole lot of sense. Why? Because when you find sine 360, of course, sine 360 will give us 0. So it doesn't matter what the other values, the values of the other quantities are, the answer is 0. You see? So this is what happens in a generator. Now when this coil begins to spin, current is induced. This is natural. Now when the current spins, or when there's a conductor moving through a magnetic field, cutting the magnetic lines of force or the magnetic flux, current is induced. This is the principle of electromagnetic induction. So the generator works based on the principle of electromagnetic induction. Electro, bring into mind electricity, magnetic, of course, magnet, induction, that is the current or EMF induced in a conductor as it moves through a magnetic field. So as it cuts the magnetic lines of force, current is induced in the loop. So that's what you have. And like I said, the amount of current or the amount of EMF, the magnitude of the EMF induced into the coil can be described in phases, in phase of right angles. So that from 0 degrees, of course, observation shows that the induced EMF is minimum. At 90 degrees, when it's turned 90 degrees, the induced EMF is maximum. And then when it turns 180 degrees, the induced EMF becomes minimum again. And then anything from 180 and above to 270, the direction of the from 180, as it turns from 180, then the induced current or induced EMF begins to rise again. But this time, the direction of it is reversed to the direction it had from 0 to 180 degrees. So when it reaches 270 degrees, the phase angle, the EMF induced is maximum, but this time the direction is opposite. You see, and then down to 360, of course, it continues like that in that same direction until it becomes minimum again at 360 degrees. So this is just the basic working principle of a generator. So the generator works based on the principle of electromagnetic induction. And what is electromagnetic induction? It is the production of current or EMF when there's a relative motion between a conductor and a magnetic field. You see, so you can revert, or you can go back to our previous videos to see what we discussed on electromagnetic induction. Thank you.